Hi, kids. All right, gonna do one more projectile problem here. I have a ball. It's kicked from the ground at an angle of 40 degrees, so you're kicking it up. If 1.2 seconds later it's traveled 15 meters horizontally, I want you to find the initial speed and how high it is at that 1.2 seconds, mark. All right, so we're going to follow our steps. We love the steps. So the first step is to draw your path. So in this case, my path is going to look something like, okay? But I don't know if it's not going to get back to the ground yet. And I know that this distance is 15 meters. And that's also 1.2 seconds away. So if I'll call this point A and just some random point D. Okay, so I'll just label it. Couple things just to remind you guys about. I don't know that it's at the peak. It doesn't say that in the problem, so you can't assume that it's at the peak. Okay, I just know that at some point along the arc. So point D actually could be here, it could be there, it could be there. I don't know. Okay, maybe at the end we'll figure that out because that might be fun. So path first. Okay, next givens. Your XY chart. If you want, I could also do this. This is 40 degrees. Okay, I know this, and we're trying to find that because I want to know the initial speed. I don't want an initial horizontal. I don't want an initial vertical. I don't know initial speed. Okay. All right, but then let's write stuff down that we do know. Okay, if I want to go from, let's say I'm going to go from A to D. If I go from A to D, that means I don't know my initial velocity and the y. I don't know what it is. So VO equals question mark. Or VO is something. My final velocity, A to D, I don't know that either. The displacement, I'm actually looking for that, so let's put a question mark there. And then my time, my A is negative 9.8 meters per second squared. I'm on Earth. And my time from A to D is 1.2 seconds. Okay, that I do. If you look, I don't know enough stuff on this side, so well, let's try the other side, okay? Because if you try to use your equations, you would say, well, wait a second, it doesn't work. I don't know enough stuff. So let's try the other side. All right, on the other side, remember VO and V, the final, they are the same, okay? But I don't know what they are, so I'll leave that there. Let's see. I know my displacement is 15 meters. That's from A to D again, so A to D. I know my acceleration is 0 because the only force acting is gravity. It's only going to affect the vertical. And I know my time is 1.2 seconds. Okay, so again, step 1, step 2. Okay, now we're going to try, well, like I said, I don't know enough stuff on this side. But wait a second. Oh, I do know enough stuff on that side. Let's do it. So if you look, V equals D over T, or X over T. I always think of it as D because it's like distance over time is speed. But if we're talking X, so if I plug my stuff in, I get 15 divided by 1.2. And if you do that, 15 divided by 1.2, you get 12.5 meters per second. Okay? So that means that this now is 12.5 meters per second. Now, and you go, okay, we know something. Where would I use that? Oh, wait a second. Oh, right. I drew my triangle over here. I know my horizontal. This is 12.5 meters per second. Well, you know what? If I know the angle in this, I could find this and this. So, I'm going to find this one because that's what the question is asking you to do. What's the initial speed? So let's do it. So that would be opposites of the cosine. It's actually adjacent equals the 12.5 over my initial speed. Okay. So if I do the math, so that's 0.5 divided by cosine 40, and I get 16.3 meters per second. Okay. So my initial speed is 16.3 meters per second. But I still need to know the height at that point. So that means I still need to know another variable. So let's find this side. Okay, so if I find that side, I'll use Pythagorean theorem just because, it's fun to use different things. I get 10.5 meters per second. Now remember, that's the speed at the beginning, so that's the speed at point A, so that would be my initial y velocity. 10.5 meters per second. Okay? Now if you look, I know this, I know this, I know this, I can solve for that. Wow, cool. All right, so I'm going to write down my equation. If I write over here, can you see? Yeah, I think you can. Y equals VOT plus 1/2 AT squared. Okay, I'm still good. All right, so if I plug my numbers in, y equals 10.5 times 1.2 plus 1/2 negative 9.8 times 1.2 squared. And if we solve for this guy, 10.5 times 1.2 plus 0.5 times negative 9.8 times 1.2 squared. You get your y to be plus 5.54 meters. So that means it was 5.54 meters up. And then, by the way, if you wanted to figure out, is it before the peak or after the peak, you could plug it in. If this was 0, that's at the peak. So if I do this in my head, so if that was 0, I'm going to go 10.5 divided by 9.8. I get 1.1 seconds. So that means at 1.1 seconds it's at the peak. So I'm a little bit past that, so I'm a little past the peak, so I drew my picture right. Yay! Bye, kids!